Today, I'll show you how I made this procedural snowflake generator in Godot 4 using the drawLine and drawPolygon functions. I put a link to the project download in the description if you want to check it out. So I found these high-resolution images on snowcrystals.com, and as you can see, there are 6 symmetrical arms with straight branches that come off at 60 degrees and hexagonal facets that make the intricate shapes and patterns. So I did my best to emulate this structure using a hexagonal grid and cellular automata, and I'm very happy with the result. So the ice crystals form in hexagonal lattice due to the polarity of the water molecules, and the more molecules in the area, the more likely they are to bond. So as the facets grow, the molecules stick to the corners more quickly than the edges, and it forms the hexagonal prisms that you see. Then the arms branch out from the corners because they stick out a bit further, and so they grow faster, and then they stick out even further, and that forms the straight arms, which branch in 60-degree angles. So it makes sense to use the hexagonal grid, and the arms can branch out along the X, Y, and Z axis. Then the facets can grow out towards the neighbors, which creates the hexagonal shapes. First, I want to draw the hexagon shapes. So in a new project in Godot, I'll make a new 2D scene and attach a script. And add the draw hexagon function. This will take a size and a color. So I'll make a new polygon of type packed vector2 array. Then for I and 6, I'll make a new vector for the coordinates, which is 0 on the X and size on the Y. So this will be the top point in the hexagon. Then I need to rotate around the center to get the other 5 points. These are all equilateral triangles, as you can see. So I'll just rotate the vector around 0. So I'll set chord equal to chord rotated, and there's 2 times pi radians in a circle, and I want to divide it into 6 parts. So that's 2 pi over 6, or pi over 3 times I to get the correct angle. Then I'll append the coordinate to the polygon list and call the draw colored polygon function, which takes a packed vector array and a color. Now this needs to be called from the draw function, which is automatically called when the scene is updated. So I'll call draw hexagon, set the size to 50 and the color to white. And now if I run it, the hexagon is up in the corner. So if I add a camera 2D to the scene, and I don't need to change anything else, it will be automatically centered with the hexagon. And of course I can change the parameters to change the hexagon, like so. Then I want to pass the position as a parameter as well. So I'll add the center point to the coordinate plus equals position. So I'll set this at 0, 0. And I can make a couple more hexagons. And change their colors as well. And now you can see it renders them in different positions. So next I'll need to line them up in the grid. So I'll make a new script for the hexagon grid, extending resource, set the class name to hexgrid, and I'll make a variable for the cells dictionary. Then I'll make a function to set the cell at a position to a value. The position is a vector 3i since all of the coordinates are whole numbers. So I'll set cells at position equal to value. Then I'll add a function to check if the cell is set at the position. This will return if position is in cells. And I'll add a function to get the cell at the position. So if the cell is set, return cells at position, otherwise return null. Now I want to convert from the XYZ coordinates into a XY grid. So for the Y dimension, it translates to the Z axis. This is 0, 1, 2, 3, -1, -2, and -3. So I'll make a new function to get the XY coordinates of the hexagon. So I'll make a variable for the Y equals position.z. Now for the X, you subtract the Y value from the X value. So -1 minus 0 is -1, 0 minus 1 is +1, and -1 minus -1 is 0. So you can see it's kind of staggered on the x-axis. So I'll set x equal to position.x minus position.y. Then I'll set the xy coords equal to vector2 xy and return the xy coordinates. Now I need to offset the x and y coordinates so they line up on the grid. For the x value, it is half of the pointed distance between the cells. So this hexagon is rotated, so we'll take the short side, square root of 3 divided by 2 times the cell radius for the distance between the x coordinates. So I'll add a cell radius variable, default to 25 or 30 so it's easier to see. Then I'll make an x offset variable equal to square root of 3 divided by 2 times the cell radius. And the y offset is half of the long side plus half of the short side. So you can see they are staggered. So this is 1 radian, or radius plus half a radius, so 1.5. And the z-axis is flipped from the y in the 2D coordinates, so I'll multiply that by -1.5 instead. The y offset is -1.5 times the cell radius. Then I'll multiply the xy coordinates by the x and y offsets. Like so. Now in the main script, on initialize, I'll make a new variable for the grid. First equals hexgrid.new. Then in initialize, I'll set the zero position to white. So that'll be in the middle, and I'll set the top right to red, which is 0, -1, +1. Set that to red, and the one to the right of the center is at 1, -1, 0, so I'll set that to blue. And I'll get rid of the draw function. Instead, I'll want to call grid.draw cells instead. And of course, we'll need to add that function to the hex grid. Draw cells. So for each cell in the cells list, so for cell position in cells, since it iterates over the index on the dictionary, I'll get the XY position equals XY coords from the cell position, and the color equals get cell at cell position. Then I'll call the draw hexagon function. So I'll cut this from the main class. And we don't need the size variable. This will be from the cell radius instead. And you can't call the draw function, the draw colored polygon function, directly from the hex grid because it extends resource. So it doesn't have a canvas to draw to. So I'll take the node 2D as a parameter as well. And then I can call node draw colored polygon from there. So that means I need a node parameter in the draw cells function as well. Now I'll call the draw hexagon function with the XY position, color, and the node. And I'll pass the main class self value. So now it draws the white hexagon in the middle with the red and blue, and it lines up with the source grid as intended. So now I'll add a initialize function to the hex grid to set the cell radius. And in main, now I can set this to 50 or whatever I want. So now the hexagons are bigger. So now I want to build an arm. I'll start from the center and draw a line to the top right corner. So to get the next cell in the northeast direction, you simply subtract 1 from the y coordinate and add 1 to the z coordinate. So you can see it goes from 0, 0, 0 to 0, negative 1, 1 to 0, negative 2, 2. So in the hex grid, I'll add a function to get the next cell position, and this will take the current position, and I'll return the position plus a vector 3 of 0, negative 1, and 1. So now in the main script, I'll get rid of the initial cells and I'll make a new variable for the cell position and set it to 0. Then for I in 5, I'll set the cell at the position equal to color.blue. Then set the position equal to grid get next cell position from the current position. So I'll run this, and now we have 5 hexagons from the center in the northeast direction. Now it would be better to actually set the grid size and build out to the corner. So I'll add a size variable, which is an int. Then in the initialize function, I'll add the size parameter. And in main, I can set that, and we'll make the grid smaller since I made the grid 10 cells instead of 5. And now I need to know when to stop building the arm. So I'll add a isCellValid function, and this will check each of the coordinates and make sure that they're not greater than the maximum size. So you can see at least one of the coordinates along the outside are 3 or -3 for every cell. So in the hexgrid class, I'll add a function to check if the cell is valid, which will take a position. So if position.x is greater than size, return false. Else if position y is greater than size, return false. So you could put this all in the same if statement. That would probably be more efficient, but this is easier for me to read. So, and then I'll check the negative as well. So else if position.x is less than size times -1, return false. Else if, so I can just copy this twice more for the y and the z. And finally, you can see that the total of the coordinates, if you add the x, y, and z up for each cell, is equal to 0. So I'll go ahead and put that check into the function as well. So -3 plus 1 plus 2 is 0. 1 plus 1 plus -2 is 0. So that works out for every cell. Else if x plus y plus z does not equal 0, then return false. Otherwise, return true. And now in the main class, I'll make a function to build the branch and move this to there. So instead of looping through I in 5, I'll say while grid cell is valid at the position, then we'll set the cell and iterate to the next one. So this will stop when it reaches the maximum size. So now you can see there are 10 hexagons since I set the size to 10 and I made the cell radius smaller, so it builds all the way to the end of the grid. Now I want to add branches coming off to the east and northwest, so I'll go ahead and add an enumerator to the hex grid. And I'll add all 6 directions, so northeast, east, southeast, and I'll go around the grid clockwise. So these will be from 0 to 5. And I'll add a direction parameter to the next cell position. So I'll add direction, which is an integer, and I'll add a match statement, which is basically a switch, and I'll add a case for each direction. Southwest, west, and northwest. And now I just need to set the vectors. So to move east is +1, -1, +0. Southwest is 1, 0, -1. Southwest is 0, 1, -1. So you can use the neighbor cells around the origin to quickly see the transform. To the west is -1, 1, 0. And to the northwest is -1, 0, 1. Then in the main script, I'll add the grid.northeast direction to the next cell call, and I'll add a fork chance, set it to 0.3 or 0.25, and now I'll say before I change the position, if rand f, so get a random float, is less than the branch chance, or the fork chance, then I'll build a side branch at the position, and I'll add a new function to build the side branch. Takes a vector 3i So I'll want to copy the code, but I'll change the direction to east instead. And I don't need to branch to the northwest because it will be reflected across the axis. So now you can see that it is building the branches. Now I don't want to have to replay the scene to generate a new snowflake. So in main, in the input function, if the event is a mouse button event and event is pressed, then I'll reload the tree. So get tree dot reload current scene. So now when I play it and I click, it changes the generation. Now I think it looks better when all of the arms are separated, so I'll go ahead and fix that. So I'll add a can fork variable set to true. Then while the grid position is valid, if can fork, and if the random float is less than the fork chance, build the branch and set can fork equal to false. Otherwise, if the can fork is already false, set it to true. And now when I run the project, the branches are separated by at least one width of hexagons. So now I need to rotate the pixels to the other side. So to reflect the cell over the x-axis, you multiply the x value by -1, and then you flip the y and z values and multiply those by -1 as well. So in the hexgrid class, I'll add a function to reflect the cell, which takes a position I'll set x equal to position.x times -1, y equal to position.z times -1, and z equal to position y times -1, and then I'll return a new vector with the x, y, and z. And now I want to call reflect cell in the set cell function. So when it sets one point on the branch, it will automatically reflect it to the other side. But I don't want to do that in the generic hexgrid class. So I'll make a new script for the Snowflake grid. And this will extend the hex grid. So I'll set the class name to Snowflake grid. And I'll copy the set cell function. So first call the super, which calls the hex grid function to set the cell. Then I'll set the position equal to reflect cell at position and call the super set cell again. And in the main class, instead of a hex grid, this will be a snowflake grid. So now if I run it, you can see the arms are reflected across the x-axis. So now I need to rotate this arm 5 more times across all 6 axes. So to rotate the cell position, you'll set the x value to the y times -1, the y value to the z times -1, and the z value to the x times -1. And this is the same no matter which quadrant you want to rotate between. So I'll go ahead and make a function in the hex grid to rotate the cell. Set the x equal to position.z times -1. Or y, and then set the y to position.z times -1 and the z to position.x times -1. So and I'll return the vector with the x, y, and z values. Then in the snowflake grid, I'll make the reflection position its own variable. And for I in 6, I'll set the position and reflection position, then set position equal to rotate cell, and the reflect position equal to rotate cell reflect. And now when I run it, you can see that the arms have been rotated and reflected around the grid. So I do want to stop these branches from growing past the middle of the top right hexdrant. So you can see they extend past and they should cut off right here. So I'll fix that. So I'll make a new function in the snowflake grid to check if the cell is in the northeast top hexdrant. This takes a position. So first I'll make sure that the x value is greater than or equal to 0, and the z value is also greater than or equal to 0, so that will return this section, the top right section of the grid. So if position dot x is less than 0, return false. Else if position dot z is less than 0, return false. So now I want to get the top half of this hexdrant, so I want to make sure that the x value is closer to, so less than, the z value is to the z-axis. So else if position dot x is greater than position dot z, return false. And this will still be true if the x and z value are the same. So the center line is still in the northeast top. And I also want to make sure that the position is a valid position. So if it's not valid, return false. Otherwise, return true. So now in the main class, instead of checking if the position is valid in the while loop for the build side branch function, I'll check if it's in the northeast top instead. And now the branches stop in the middle to make the triangles, and they don't extend past the center line. So that looks much better already. Now, if you look up snowflakes on Google, you can see that not all of the side branches make it all the way to the center. So there's a gap down the middle of the hexdrant. So there's another one, and that makes the shape look more interesting. So in the build side branch function, I'll add a variable for if the branch has ended and set it to false. Then in the while loop, if the grid is in the if the position is in the northeast top quadrant and the branch has not ended, then set the cell, and I'll make a branch end chance equal to 0.2. So if a random float is less than the branch end chance, then set branch end to true. So now if I run it, you can see that they stop sometimes before they reach the center. So I can increase the chance or decrease it depending on the grid size. But so this just makes the patterns more interesting, in my opinion. So now I want to grow facets along the arms. So first I need to make a function to get a random element from a dictionary. Since the cell list is a dictionary, and I'll get a random position along the arms. So you get the keys from the dictionary.keys, then the index equals a random integer modulus the dictionary or keys.size, and return keys at index. So this will return the random key from the dictionary. Then I'll add a function to build the facets. So this will get I'll add 10 facets since the grid is pretty small, and set the position equal to random dictionary and pass the grid dot cells array or dictionary. Then I'll set the cell at the position to purple. Since I only have the arm set, the grid.cells only has the populated cells, so the facets should always grow on the arms. So I'll call the build facets function, and now it randomly turns some of the cells purple, as you can see, but it still keeps the overall shape. So now I want to grow the facets to the neighboring cells. So in the hexgrid class, I'll add a function to get neighbor cells from a position. So I'll make a new array for the cells and iterate over all 6 directions. So next position equals next cell from the position in the I direction, and then append to the neighbor cells the next position and return the neighbor cells. And I'll go ahead and make sure the position is valid first. So if is valid, next position, then append the neighbor cell to the list and return the list. Then in the main script, I'll add a new facets array to keep up with the facets. So append the position to the facets list in the build facets function, and then I'll make a function to grow the facets, and I'll call that at the end of the build function. So here, for cell in facets, I'll want to get the neighbors. So for n in grid, get neighbors. If you save it, then it'll show up in the autocomplete. So we'll get the cell neighbors, and then in the grid, set cell position color dot red. So if I'll go ahead and check. I'll get the next cell equal to get cell at next position, and if the next cell equals null, then set the cell to red. Otherwise, if the next cell equals color.blue, then I'll set the cell to purple. So this just lets me see the arm structure still. And now when I run it, you can see that the facets have grown and it looks a lot more like a snowflake now. So this looks pretty good at this size, but if I make the grid bigger and turn down the resolution, you can see that the facets are pretty small and you'll want to grow them out beyond the first row of neighbor cells. So to do this, you'll need to keep track of all of the new facet cells as you grow them. And I could add them, I could make the facets an array of arrays, but it will be easier for me to manage this if I make a facet resource instead and make this an array of resources. So I'll do that. So I'll make a new script for the snowflake facet, which inherits resource. I'll set the class name to snowflake facet and add a cells array. Then I'll make a function to add a cell position, and this will check if position is in cells, and if it's not, then append the position to the cells array. And then in the initialize function, I'll take a starting cell position and call the add cell function on that. Now in the main script, I'll set the facets variable to type snowflake facet array, and in the grow facets function, I'll loop over the facets and say for cell in facet.cells, and then loop over the neighbors to grow the, and if you do set the cell, I'll call facet.addCell at the neighbor position, and in the build facets, I'll make a new variable for the facet at the position, and then append the facet to the facets list instead. So now when I run it, it fills in the entire grid. So what I need to do is make a duplicate. So facet cells equals facet dot cells dot duplicate, and then we'll loop over the dupe cells instead. And now the growth radius is limited to 1 iteration. So now in the build facets script, I can say for I in 3 grow facets, and this will make them grow 3 times. And I also want to move the grow facet function into the facet class for convenience. So I'll add a grow function, and I'll add a grid variable to the class, which I'll set in the constructor. So now it has access to the grid variable, and so it'll duplicate the cells in the cells list and call add cell directly. And in main, for the grow facets, for f in facets, facet.grow, and I'll pass the grid as an argument to the constructor. So you do need to assign the variable and try again. So now it still works, which is good. Now it's not very efficient to get all of the neighbors since the internal cells can't grow. So I'll add a new array for the growable cells of type vector3, and when you add the cell, I'll get the neighbors grid.get neighbors at position, and if the neighbor position is not in the growable array, then append the neighbor position to growable. And I also need to remove the position that it grows to from the growable list. So you'll use erase to erase the variant instead of remove, which is if you know the ID. So you can directly remove the variant from there. So now in the grow function, I'll set the dupe cells to growable.duplicate instead, and then I don't need to iterate over the neighbors. So next cell equals grid.getCell at cell. I'll replace the n with the cell variable. And now if I run it, you can see that the facets are still growing, but this is much more efficient. So next I want to actually draw the lines and polygons instead of using the cells on the hex grid. So I'll make a new script for the Snowflake branch extending resource. I'll set the class name to Snowflake branch and add variables for the start position, end position, and the grid. Then I'll add the initialize function, which will take the start position and the snowflake grid. So I'll set the start and end position to the position and set the grid to G. And I'll make a function to add a cell to the end of the branch, which will update the end position. Now in the main class, I'll make a new array for the branches. Equals an empty array. Now in the build branches, I'll set the first value in branches to a new snowflake branch at position on the grid, and when it sets the cell, I'll update the first branch so I'll call add cell to update the end position. Then in the build side branch, I'll make a new variable for the branch equals new snowflake branch at position on the grid, and when I set the cell, I'll update the branch again, and at the end append the new branch. So I'll run that, and it didn't throw an error, so that's good. Then in the snowflake branch class, I'll add a function to draw to a node 2D. So I'll get the start position equals grid XY coordinates of the start cell, and the end position is the grid.xy coordinates of the end position. So then I'll call node.drawLine with the start position, end position, set the color to white, and the width of the line to the grid cell radius times 2. And now in the main class, in the draw function, I'll iterate over the branches and call the branch draw function on self. So now it draws a white line on the northeastern hexdrant of the snowflake, and I want to rotate this around like we did the cells. So first I'll make a function in the snowflake branch to reflect the coordinates. This will take a coordinate list, which is a packed vector2 array. Then I'll make a new list, which is also a packed vector2 array. And for coordinate in coord list, I'll set coordinate dot x times equal -1. So I'll multiply the x coordinate by -1, and then I'll append the coordinate to the new list and return the new list. This just reflects the xy coordinates over the y-axis. So now in the draw function, I'll make a new variable for the coordinates, which is a packed vector2 array, and this will be constructed from an array of the start and end position. And I'll make a new variable for the reflected coordinates equal to reflect coordinates with the original coords. Then I'll draw another line from the reflection coords at 0 to reflect coords at 1. And now it is reflecting them across, and once I rotate it, it will fill in all of the arms. So I'll add a new function to rotate the coordinates. I'll copy the reflect, and for each coordinate in the list, I'll rotate by, so there's 2 pi radians in a circle, so divided by 6 is pi over 3. And I'll set new chord equal to chord dot rotated and append the new coordinate to the new list. And in the draw function, I'll iterate over all 6 directions and I'll change the start and end position to coords 0 and coords 1. Then I'll update both lists to the rotated coordinates. Like so. So now it draws the white lines on all of the arms. So now I want to outline the facets, and I don't want to use the inner outline because if the facet only has one cell, it'll be a single point, and if it has 2 cells, it'll be a line instead of a polygon. So I'll take the outer perimeter of the facets instead, and I already have the growable cells array, so I'll use that to calculate the coordinates. So in the Snowflake facet class, I'll add a draw function like we did in the branches class. So this will take a node 2D. Then I'll make a new variable for the polygon, which equals a new packed vector2 array to hold the coordinates. Then I'll loop over the cells in the growable list and set the position to grid at XY coordinates of the cell. And append the position to the polygon list. Then I'll call node draw line, or draw polyline. So this will take the polygon and a color, which I'll set to black, and a width, which can be 2 or 3, just so we can see it. And now in the main, whenever I call the draw function, which gets called automatically, I'll loop over the facets and call the draw function for each one. So this will draw a squiggly line because the growable cells are not added in order, they're just randomly added as it grows. So I want to basically sort the growable cells as I add them so that this will make a polygon instead of a squiggly line. So I did try several ways of adding the growable cells in order, and I got pretty close. So you can see that it is outlining a polygon, and it looks pretty good, but it's not extending to all the cells, and sometimes it freezes like that, and I haven't figured out why. So I figured it would be more efficient, since this loops through the list several times anyway, to just make a function to calculate the outline separately. So I'll put the add cell back to the way it was, and I added a check here to make sure it's not in the cells either. So previously it was just if the neighbor's not in growable, but I added the if it's not in the cells list as well. So it's back to the squiggly lines. So I'll get rid of the previous attempt and add a function to get the outline. And first I want to get the topmost cell, which will give me a starting point that is guaranteed to be along the perimeter. And I'll make a function to get the north cell. So in the grid, as the cells move upwards, the z value increases. So I'll find the cell with the highest z value. So I'll set the initial position equal to 0, then loop over the cell indexes in cells.size, and if the cells at cell index is greater than .z is greater than cells at top cell .z, then set top cell equal to cell index and return the new cell index from there. And actually I want to return the top cell position in the cells list, so this returns a vector 3. Now to increment the perimeter, I'll take a position of the previous cell and the direction it was in. So for each direction, I'll set dir equal to direction plus 1, since I know the cell in the previous direction is part of the outline. So I'll rotate counterclockwise, or I'll rotate clockwise and modulus by 6 so that it wraps. Then I'll get the next position equal the grid dot next cell position, and this will be from the position in the direction. And so this will keep rotating until it finds a cell that is not already in the cells list, so it'll be outside the shape. So if next position is not in the cells list, then return a dictionary where position equals next position and direction equals direction. Now this will be the forward direction from the previous cell, and I actually want this to be inverted so it points backwards. So I'll set direction equal to dir plus 3 and modulus by 6 again. So in the getOutline function, I'll make a new variable for the perimeter array, and I'll set top cell equal to grid.nextCellPosition from the previous top cell in the north direction. So then I'll make a new variable for the next cell, which is a dictionary. Set the position equal to top cell and the direction equal to 3, which is opposite to the southwest, so 0 is to the northeast. And then while the next cell position is not in the perimeter, append the next cell position to the perimeter array, and then set the next cell equal to increment perimeter, and I'll pass the next cell position and next cell direction. Then I want it to loop back at the end, so I'll append the final cell, which should be the first one, and we'll append the next cell position, not the cell itself. Then I want to convert the cells to the XY coordinates, so I'll make a new variable for the polygon, which is a packed vector2 array, and for position in perimeter, I'll get the grid.xy coordinates of the position and append it to the polygon, and I'll return the polygon instead of the cells list. So now in the draw function, I'll set the polygon equal to the getOutline function, and now if I want to run it, I can see that the facets are being drawn as a complete polygon. So now to fill them in, I'll make a new color equal to color dot blue, and then I'll turn down the opacity to 0.5, and I'll call the node draw colored polygon function, pass the polygon points and the color to that, and if I run it again, the facets are filled in. And you can see they are completely overlapping the edges, so it doesn't get cut off. So next I want to rotate these around and reflect them like I did the branches. Next, I want to rotate and flip the facets, so I'll use the functions from the branch class, but instead of copying these functions or moving them to a utility class, I'll go ahead and cut the rotate and reflect functions and make a new script for a Snowflake segment, extending resource, set the class name to Snowflake segment, and paste the reflect and rotate coordinates here. Then I'll make the Snowflake branch and the Snowflake facet both extend the Snowflake segment. So now I have access to that class, the rotate and reflect functions. Now in the facet draw function, I'll get the reflected polygon from reflect coords on the polygon. Then I'll iterate through all 6 directions, and I'll move the color out of the loop. So I'll want to draw the polygon and the reflect polygon, and then set the polygon to rotate coords and the reflected polygon to rotate the reflected coordinates, or poly. So now, when I play the scene, you can see that the facets are rotated and they completely cover the red hexagons, so I know that the border is working. And I can disable the draw cells. So now it's just the lines and the polygons. Next, I want to change the way the facets grow. So instead of it guaranteed growing if the next cell is empty, I'll add a random chance depending on how many facet cells are next to it, so it's more similar to the way the actual snowflakes grow, and it will add more variation. So in the snowflake facet class, I'll add a function to count the neighboring facets from the cell. So first I'll call the grid.getNeighbors and set that to a new variable. Then for each neighboring cell, if the position is in the facet cells list, then add 1 to the neighbor count. So I'll make a variable for that at the top, set it to 0, and then I'll return the neighbor count at the end. And in the grow function, I'll get the neighbor count from the next cell position and calculate the grow chance, which is neighbor count divided by 6, and I want this to be a %, so I'll make that a float, otherwise it will always be 0. So there is at least one neighbor, so this is 15% minimum, and up to 100% if it's completely surrounded by facets. So now if a random float is less than the grow chance, then grow the cell, otherwise do nothing. Now if I run this, the facets only have a single cell in them, and that's because the grid has vector 3i, but the getNeighbors returns a packed vector 3. So in the hex grid, in the getNeighbors function, instead of setting neighbor cells to packed vector 3, I'll set it to an array of vector 3i equals an empty array. And now when I run it, you can see that the facets are actually growing in a more organic shape, so it's not all straight lines. So I think that looks a lot better. And I can increase the grow iterations in the build facets function. So if I set it higher, it fills in more. And I'll increase the grid size to 50 and lower the resolution to 5. So now you can see it has a lot more details. Next, I want to create a gradient so the colors change from the inside to the outside of the snowflake, and I want to keep them within the range of blue and cayenne. I want to color in the facets according to their distance from the center. So in the hexgrid class, I'll add a function to get the distance from center, which takes a position. So I'll get the absolute value of the position dot x y and z. So basically, even if it's a -3, it is still 3 pixels from the center. So I'll get the absolute value and then the maximum value of the 3 coordinates and return that. So return max of x, y, and z, and then I'll get the % from center, which will get the distance from center I'll make a new variable and cast it as a float. Then return the distance divided by the size. Now in the facets class, I'll add a color parameter to the draw function, and instead of setting the color and alpha there, this will refer to the parameter instead. Now I also want to add a variable for the origin to the facet class so that I can calculate the distance from the center, and in the initialize function I'll set the origin equal to the position. Now in the main class, I'll add a variable for the color gradient equals a new gradient, and in the draw function I'll make a variable for the color which equals color gradient dot sample at the grid get percent from center from the facet origin, and I'll pass the color into the facet draw function, and now you can see the color shifts from black to white at the end. So now I want to generate the random blue color instead. Next, I'll make a function in the main class to generate a random blue color. I'll make a variable for the color and set the red value to a random float between 0 and 1. So this will allow the color to range from blue all the way to white. And I want the green color to be from the red value to 1 so that it's more green than red. This avoids the purple and pink colors. And I'll set the blue to 1 and the alpha channel to 0.5. Then return the color variable. And now in the initialize function, I'll set the color gradient at index 0 to a random blue color, and I'll set the index 1 to a different color, and I'll increase the number of facets to 20. So now you can see that the snowflake shifts from one color in the middle to a different one on the outside. And I think this looks really nice. So now I'm going to optimize it, although it does run pretty quickly. So in the snowflake grid, instead of storing the cells as colors, I'll store them as integers. So I'll add an enumerator with none, facet, branch, and facet branch. And I'll add a function for isFacet at position if cells at position equals facet, or cells at position equals facet branch, return true, otherwise return false. And I'll make another function is branch. So I'll check if it's a branch or a facet branch, return true, otherwise return false. Now I want to override the draw cells function from the hex grid, so I'll copy that to the Snowflake grid. And I'll make a variable for the cell value equals cells at cell position. Then I'll set the color to white. Then if the cell equals facet, set the color to red. Otherwise, if the cell equals branch, set it to blue. And if the cell equals facet branch, set it to purple. Now in the main class, when I set the branch, I'll set the cell value to grid.branch instead of color.blue. And when I add the facets, this is the facet branch. And in the Snowflake facet class, instead of red, I'll set it to facet. And facet branch instead of purple, and then check if it's a branch. So now when I run it, it still works. So that's good. I also want to make sure the facet isn't already set when I initialize, so I'll add a while loop. While position is in facets, reset the position. So this way, if the position is already in the facet list, it will get a new one, and it will always make 20. So now, since the grid is symmetrical, I don't actually need all of these other cells in memory. I can just store the top half of the northeast hexdrant. So I'll go ahead and do that. So I'll get rid of the set cell function in the Snowflake grid and just let it set the values individually. And now if I just call the draw cells function in draw, you can see that only the top branches being filled with facets. So now if I run it again, you can see that it still makes the snowflakes. There is a lot of overlap in the middle here, so I kind of like how the facets overlap with each other, but I'm going to constrain them. So in the facet grow function, we'll say if grid in northeast top cell position then grow the cell, and now there are no overlapping facets, so you can easily see the branches underneath. So I think that looks really good. I'll be adding this to DerpStar in the near future. So thank you so much for watching. I really appreciate your support, and have a great day.